Okay, now we continue to the second part of today's asynchronous lecture. We proceed with example 2. Okay, so example 2 here, a ladder 10 feet long rests against a vertical wall. Okay, so if this kind of question, if you are, kalau you boleh lukis to illustrate the conditions, please do. Okay, so let's try. Okay, let's try. We have a vertical wall, katakanlah ni dinding lah. Okay, dinding. So there is a ladder 10 feet long rests against a vertical wall. So maknanya 10 feet long. Okay, ni dah tangga tu. Okay, kita ada tangga kat sini menyandar dekat vertical wall here. So the length of this ladder is 10 feet, right? Okay, if the bottom of the ladder slides away from the wall at a rate of 1 feet per second, maknanya asal dia asal tangga tu dia duduk selari dengan dia duduk bertempek ke selari ke dengan dinding ni. Okay, so kita katakanlah ni tangga tu ada kat sini. Okay, but as time goes by, tangga tu makin lama dia bergerak. Macam tu. Okay, it slides away from the bottom of the wall. Okay, away from the wall at a rate of 1 feet per second. So maknanya position dia sekarang berada sini. So jarak dia daripada the distance between the ladder ni from the wall is changing at a rate of 1 feet per second. Katakanlah saya kata jarak daripada wall ni kepada bottom of the ladder ni is x. So in this case maknanya dx over dt is equals to 1 feet per second. Okay. Then the question asks, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Kalau dalam kelas ni saya demo dah. Okay, but yelah virtual ni pandai lah kita imaging. So maknanya macam tadi saya kata dia makin lama dia menyelusur jatuh. So maksudnya jarak yang ni pun makin lama makin bertambah ke makin berkurang? Dia akan makin berkurang. Asal dia duduk tegak macam ni kan. Lepas tu dia bergerak macam ni. So maknanya asal dia tinggi macam ni. Then when it goes down, it slide away. Then here the distance going down. Makin jatuh. Bukanlah. Dia makin jauh macam tu. Okay. Then until it finally it fall down. Kan. Daripada atas ni, dia jatuh, it fall down, so the distance becomes 0 lah. So, for this case, maksudnya, we say it this y. Hopefully, you understand lah. Kalau you tak faham, you pergi ambil pen ke, ataupun you buat eksperimen lah dengan adik-beradik you dekat wall tu. Bukan tu ambil tangga, letak dekat wall, nampak tak dia makin, yang jarak kat bawah tu makin bertambah, yang atas tu vertical, y ni berkurang. So the question asks, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So maknanya the question asks us, what is dy dt equals to what when x is equals to 6 feet? Okay, so what is given to us? Kita ada 10 feet, is this the length of the ladder? And we have the rate of the bottom slides away from the wall. Dx dt is equals to 1 feet per second. We don't know what is y. Even dy over dt pun kita tak tahulah. But we know that and the question wants us to find what is dy dt when x is equals to 6 feet. Right? Okay, so here, first thing is equation is not given to you. But we have this illustration. Okay, so kalau you tengok gambar ni, okay, we denote the variable x dekat bawah ni, the distance of the bottom, and the vertical one is y. So kalau yang kat sini dia akan jadi 90 degrees. So what is the best equation that we can relate with this condition or situation? Of course, kita ada hypotenuse, ingat tak? Okay, where we have here x square plus y square equals to 100 or 10 square kan. X square plus Y square is equals to 100, 10 square. Okay, saya erase tadi and I tulis cantik-cantik sikit lah. So we have X here. Okay, Y here and 10 here. So from here maknanya kita ada X square plus Y square equals to 10 square or 100. And what is given to us? Okay, dx over dt is equals to 1 feet per second. Then we know that the question wants us to find what is dy over dt at x equals to 6 feet. Alright. So from here, kita daripada equation ni, what we can do, okay, to get dy dt, we know what is dx dt. So in this case, maknanya we are to differentiate both sides respect to t. d dt of x square plus y square equals to 100. So when you differentiate this, what you will get, okay, we get implicit differentiation lah ni. 2x d dt of x, so become dx dt, plus with 2y d dt of y, so dy dt equals to d dt of 100 is a constant, so you get 0. Okay, and kita tahu dx dt is equals to 1 feet per second. So from here, we have 2x darab dengan 1 tambah dengan 2y dy over dt equals to 0. Okay, so the question asks you to find what is dy dt, but yet we have x here and we have y here. So meaning to say our x is equals to apa? X is equals to 6. But still we do not know what is y. Kita tak tahu apa ini y, apa value y, but we do have this equation. Okay, we do have this equation. So maknanya kita ada x equals to, okay, x is equals to 6. So 6 square plus y square equals to 100. Then from here we have y square is equals to 100 tolak 36, so it's 60. 4y square, then here we know that y is equals to square root of 64, then 8 lah. Okay, betul tak? Punca kuasa 64 is 8. So from here maknanya 2x 2 darab 6 darab dengan 1 dx dt is equals to 1 tadi kan. Mana dx dt saya tak tulis ni. Ni. dx dt equals to 1 plus with 2y 8 dy over dt equals to 0. Having this, maknanya kita dah, okay, boleh nak selesaikan what is dy dt. In this case, meaning to say dy dt is equals to negative, okay, 12 over 16 or equals to negative 3 over 4 feet per second. Okay. Alright. Okay, so we're done with example 2. Okay, so now we proceed to example 3. In this example 3, the question said, assume that oil spilled from a ruptured tanker spreads in a circular pattern. Circular, apa maksudnya? Circle lah. Calculate the rate of change of the area when the radius is 60 meter. If the radius is increasing at a constant rate of 2 meter per second. So, kita punya variable kat sini adalah apa? Adalah area dan juga radius. So, what is given to us? R is equals to 60 and the rate of the radius is increasing is dr over d. D is equals to 2 meter per second. Okay, so faham tak? Maknanya dia ada tanker. Okay, tanker ni ruptured, bocor, pecah. Okay, ada keluar minyak. So, minyak ni dia keluar melimpah dalam circular punya tu. Okay, permukaan berapa banyak minyak melimpah ni dalam circular punya shape. Alright. So, we have area. Kita nak cover area. Rate of change when area of the area. Rate of change of the area. So maknanya soalan tu nak how much is the area change in respect to time. dA over dt is equals to what? We have dr over dt. Okay, so here boleh tak you all relate A dengan R of area of a circle? Apa dia punya formula? Area A is equals to pi R square, betul? Okay, area is equals to pi R square. Okay, so daripada sini apa lagi yang kita tahu? Dah tak ada apa kan? Kita just have radius equals to 60 and dr over dt is equals to 2 meter per second. Okay, so meaning to say untuk dapat dA over dt, the whole equation here we are to differentiate respect to t. Okay, so here maknanya kita dapat d dt of A. So because we know A is changing respect to time, so we have dA over dt and pi r square d dt of pi r square. Okay, so respect to kita tahu pi tu constant, so pi tu letak kat luar, it's just that d dt of r square. So with this we have differentiate r respect to t. So macam biasa 2 turun bawah, r kuasa reduce by 1 and do not forget d dt of r. And okay, so daripada sini kita dapat 2 pi r darab dengan dr dt. So very straightforward. dA over dt then equals to 2 darab dengan pi. Your r is equals to what? R is equals to 60 darab dengan dr over dt is 2. Okay, dr over dt is equals to 2. So your final answer will be 240 pi meter square per second. Okay, right, so with this we have answered example 3. Alright class, so now I have solved example 2 and example 3. So for example 4, now it's a turn for you to solve as your classwork submission. Dah lama saya tak bagi kan classwork submission. So this time special, I dah bagi jawapan. I nak you work out je macam mana boleh dapat jawapan ni. Okay, so for A, jawapan dia 120 pi. And for B is equals to 5 centimeter. Alright, so I want you to try on your own, work out this example 4 until you get this answer. Alright class, so that's all for part 2 asynchronous lecture.